Hi, today I am going to give a little demo about Mini-NDN. Mini-NDN is based on Mininet network emulator. Mininet can create a virtual network on a single machine. Mini-NDN runs the NDN stack on this network. It provides a simple way to configure a topology and run an experiment. So let me show you how to install Mini-NDN. There are two ways to do it. You can use the automatic script that we provide, which will install the dependencies as well as Mini-NDN, or you can do it manually yourself to have greater control over the versions that you want to install for the NDN stack. So you can simply use sudo /install -h to see all the options, and if you want this script to install all of the dependencies for you, you can use all the options together. So for example -fimt, and this will install all the dependencies and everything will be ready once the script is done, so that you can simply run Mini-NDN. Let me show you just the manual method to do it. So you need to get ndn-cxx. So here I'm going to use an older version of ndn-cxx and NFD and chronosync. So whatever version you choose here, you can install that in the system, and that's the version that Mini-NDN will use. Here I am assuming that you already have the prerequisites required to compile ndn-cxx, NFD, chronosync, NLSR, ndn-tools, etc. To install Mininet, you can simply use the zip script that they provide and use that with an option -n, which means just install the core dependencies, because that's all Mini-NDN needs. And then to install Mini-NDN, use the install.sh with the -i option, which means only Mini-NDN, since we have installed the dependencies ourselves, having complete control over the dependencies. To run Mini-NDN, use sudo mini-ndn. Mini-NDN starts each node one by one, and on those nodes it will run an NFD instance. All these nodes provided by Mininet are simply bash processes running in their own network namespace, and we connect these processes using virtual Ethernet pair to form links. You can see that on a single machine you are running multiple instances of NFD and multiple instances of NLSR. The configuration files and the log files are stored in the temp folder by default. Now if you want to interact with NFD and NLSR on a node, you can issue A, which is the name of the node, followed by NFDC, and if you want to see, for example, the fib of the NFD, use fib. So it shows all the entries that the routing table has configured in the fib. If you want to see the topology, you can do net. So when I did sudo mini-ndn, it used the default topology that was installed in the system when you install Mini-NDN, which is a 4-node topology. Let me show you how that topology file looks like. So you have the nodes section, which defines your nodes. It contains your node names, and the links section, which contains the links between the nodes. You can specify configuration parameters like the delay of the links. Other parameters include bandwidth and loss. So if you want to see the logs of the NLSR running, you can access the log file. If you want to interact with NLSR, you can send a status command and see the routing status. You don't have to use this terminal if you don't want to. You can use an xterm running on that node, which will give you an easy way to run your commands. Or you can also export the home folder in the new terminal and access the NFD running on that node. To quit Mini-NDN, simply use quit. And if you want to store your logs, you can access them in temp. To know the details about the options that Mini-NDN can take, you can issue sudo mini-ndn --help. and it will show you all the options that Mini-NDN can take. For example, if you want to specify any other work directory other than the temp folder, you can use --work-directory. If you use --testbed, it will use the testbed topology, which is a snapshot of the 22 node testbed, and use that topology to create the network. Using NLSR security, you can start NLSR with security configured for you. And using --experiment, you can specify your own experiment to run. So let's say we want to create a new topology. So you can either use the Mini-NDN GUI, which is an extension of the Mininet GUI, or you can modify the topology file by hand, or you can write some basic scripts to generate topologies like mesh topologies or linear topology, etc. So let's modify the default topology to make an even more simpler topology. So all the topology files are stored under utils, topologies, and let's just have 2 nodes here. So to run with that topology file, you specify that topology file. So after a while, we will see that NFD has got the routes that NLSR has installed. So it has got the router from B, and if we wait for a while, it will have the name prefix announced by B as well. Yeah, so it got the name prefix that's announced by B. So what I do is I just open a new terminal and export the home folder for B, and let's run ndn ping server on the prefix that's announced to A. And let's open another terminal where I export the home folder of A. So what exporting the home folder does is it gives all the applications a way to connect to the NFD running on that folder, as I mentioned earlier. Now if I do ndn ping, let's say 5 pings, so you saw that we configured a delay of 10 milliseconds and you get about twice for the RTT time. So what if we want to do this programmatically in an experiment file, so that we don't have to do this over and over again? So the experiment files are stored under ndn experiments, and let's have a look at for example, the experiment manager class and experiment class. So you have functions to check that NLSR has converged, and after that you can, once the routes are announced, you can set up your own experiments. So if you look at the convergence experiment, it only checks the convergence, and for run it does nothing. So what I will do is I will copy this experiment into a new file and create my own experiment. So let's change the name of our class to custom experiment, and this is the name that you will specify at the command line of Mini-NDN. So just choose like custom maybe, and here what you can do is there is a net object which contains all your hosts. So you can do self.net and specify your node name. So we will call this node A, and then you can run a command on node A. So that will run your ping server on node A, and on a prefix that's announced by the NLSR on node A, so that node B can reach it. So you will have to output all the stuff to some file, or maybe do it to a dev null if you don't need the logs, and run it in background. So it's basically like running a bash process on the node. You can specify any file here instead of dev null, and that will be stored under your node home folder. That would be your /temp/a or some /work directory /a if you have different work directory. And you can actually directly use the net nb. Let's do maybe like 10 pings, so that will take 10 seconds. And let's store it in a file. So now for if you want to use this experiment with the -- experiment option of Mini-NDN, you'll have to first install Mini-NDN again. So now if you do Mini-NDN --list experiments, okay, so it shows an error and it tells you why it went wrong. So you can just correct the error. I changed the name for custom experiment at the top, but forgot to do here. So install again. And then let's see if, yep, that works. So your custom experiment is here. So to run it, so I'm just checking that whether my working directory is empty, and so that I have clean logs. Do --, so first specify the topology, and then experiment custom. And if you have, for example, a slow machine, you can specify a convergence time parameter for an LSR. By default it is 60, so maybe increase it to 70, because scaling depends directly on the power of your CPU, and if you don't have a powerful CPU, an LSR might sometimes take more time to converge. But on a 2-node topology, it should converge in the default times of 60 seconds, so I'm not going to use it. So if you look at the experiment, first it will set up. So in the setup I check the convergence, that whether an LSR has converged. Only then you should run any program so that it can route properly. So that's what it says, like waiting 60 seconds for convergence. It's waiting for an LSR to converge. So what convergence means is after 60 seconds it will go through each node's fib and check that all the other nodes router prefix and name prefix are installed there. Hopefully we have the logs in the temp folder. Yeah, so I see the Indian ping text folder. Let's see if it has. Yeah, so that's how you can run. You can program your own experiment to run on whatever nodes you want, and run whatever program you want on any node. So simply make sure that your program is either installed in the system, so that you can directly access. For example, ndn ping was installed in the system, and if you write a custom program, either install it in the system, or you can also specify the full path to your program. And so basically just what you do in bash, or in your shell scriptings. So now let's see how you can. So for example, you want to maybe modify NFD and see the changes, like what's going on inside NFD. So let's see where you can specify the log levels for any module of your NFD. It's in the configuration file that's installed in the system, which will be copied to each of your node's home folder and then used with NFD. So you see I have set ASF strategy to all. Let's change that to maybe trace. And you need to set the ASF strategy as the default strategy in Mini-NDN, because by default NFD has the name prefix / under best route, but with ASF strategy, which is used in the testbed in conjunction with hyperbolic routing, what ASF strategy does, it comes over the suboptimal paths, if any, provided by the hyperbolic routing. So it's an adaptive forwarding strategy used with hyperbolic routing. So to turn it on, you can go to the experiment.py folder file. So self strategy, which is the default best route. Instead you can write ASF. And so you will have to install Mini-NDN again, because you made a change and you need to get the change into the system. So now if you run the experiment, any experiment would do, but yeah, I'm just using ping all, which is just each node pinging every other node. So let's see if we have any messages already in the log file. Yeah, so ASF strategy is already kicked into action, because /ndn is also in our router's names. So ping scheduling has started, and LSR is successfully converged. And yeah, so it has started pinging, and ASF strategy is trying to decide which phase is best, and it's giving some readings that it has taken for how each phase is performing. So now maybe if I want to add a custom message to this, for example, you're working on your own custom strategy and you want to add a message, so you can go to your NFD folder and modify your strategy. Search for trace and say just some random. I need to compile it. Yeah, one thing you have to make sure every time, like you compile, you have to install, either you're working with NFD, Mini-NDN, or your own custom application. Let's end this experiment. So if you look at your temp folder, you have all these logs in the ping data. And you can write some basic bash and GNU plot script that you can use to plot these data, or you can get whatever timing information you want and use that in your experiments, in your papers and in your demos or whatever. let's see if our NFD, yeah, so I installed NFD, and now that random keyword should also show up when I run it again. Yeah, as opposed to an simulation, Mini-NDN which is an emulation, will be slower because it's real time. I mean, you cannot simulate time here, so it might appear to be slow. So unlike if you have some faster machines, we can do some optimizations like run it on a RAM disk and store your results in a RAM disk for faster write, and you can decrease the time that NFD needs after it starts. So it sleeps. It needs to sleep for 2 seconds. You need to sleep for 2 seconds after NFD start in Mini-NDN. So these timings can be reduced on a faster machine. But we do also have the cluster edition of Mini-NDN, which can scale, but it's not very thoroughly tested. It's based on the cluster edition from Mininet, and we have tried to just use that to scale our operations, and we are still trying to test it. So if anybody is interested to try it out, we would love to hear your feedback. Yeah, let's just check the files if it already has some messages. Yeah, so yeah, it has the random. Oh, I misspelled random there. It has some message. The message that I modified showed up in the logs, and again you can write your own scripts to parse these logs, draw graphs, and present it in your research. So with the simulator, that is the ndn sim, you're limited to develop your applications against ndn-cxx. But in Mini-NDN you can also run applications from, like if your application is written against, for example, the common client library py-ndn, and that will just run fine. I mean, it's just the real system. You can run any application, and any application you write for Mini-NDN, you can just put it in the real environment. So basically it is somewhat close to the containerization. You have your application, you develop it, it works in your container, and it should work as expected on the main testbed. And if you have a powerful machine, you can have the 37 or 38 nodes that current NDN testbed have, emulate them, run your application beforehand to see how it would work on the real testbed. We use Mini-NDN for NLSR. I've used it to debug chronosync. I've used it to develop the psync, the synchronization protocol for pub subs, and Mini-NDN is used regularly for testing NLSR on the testbed. I mean on our Gerrit. So for NLSR it gives a score. We run NLSR in an emulation, so we just run it in one machine and we have a network to test. We don't have to set it up ourselves, take care of all the configuration files. For example, we used to use Emulab a long time back, and we have to wait for the nodes to get available, and we have to synchronize the nodes. We have to use some parsing files to configure the configuration, but all that is just automatic in Mini-NDN. It has been done for you. You can use it with very simple commands. So yeah, I was showing you. Yeah, so this is the bot that we have developed. It works over Mini-NDN. So if you have an application that wants continuous integration testing, that you know that you need to deploy on some testbed, you can use it for continuous integration testing. You just build an experiment, specify what the experiment should do, and post the result to wherever you want to. So you can join our mailing list, which is, if you go to the GitHub page of Mini-NDN, it's right there. If you have any questions, you can ask here, and if you have any bugs to report, you can go to the Redmine and file an issue here. and there are some docs that you can use to get started with Mini-NDN. So apart from like having like develop applications on various, maybe with Python or with the JavaScript libraries, you can also connect the nodes of Mini-NDN to outside world, which we describe here, connecting to outside, how to do that. And the cluster setup is also here, which we are in the process of testing, so to make it more robust. Please try to use Mini-NDN. We would love to hear some feedback. And if you're just getting into the NDN, it's a very easy way to get started. You don't want to just start with the core forwarder if you don't know. It will take some time. So if you want to play around with a network that's running NDN, and you don't have many resources, you just have a laptop with you, you're a student, you're a researcher, you can install Mini-NDN, run it. So and one more fair warning is, like, just be careful that Mini-NDN runs with sudo. So don't like do a remove -rf/ inside your code. So that's just be careful about that. Or maybe run it in a virtual machine. That's the best case, so that you don't destroy your precious data. So thank you again, and I hope to hear from you on the mailing list.